Hey everyone, it's Matt here with Nightrun Studio, and in this cutscene video, we're going to look at how to add an element that pans the camera over a set amount of time. This will work whether you're using Cinemachine or not, as I'll show both options. Let's get started. While these cutscene element videos are meant to be mostly standalone, they do assume that you've seen the first video where we set up our cutscene handler and initiator. With that done, we're ready to start. So essentially what we're doing for the pan element here is just taking your camera and using its transform component to smoothly slide it from one position to another. So to get started, let's create a new C# script called cutscene element _ camera pan. Now we can start off by getting rid of the start and update methods, as we won't need those. We're going to make a public override void called execute. And this is just the method that gets called every time we start one of these elements. Now at the moment, you're going to see that red underline. That's just because this is not a mono behavior script, and we need to make sure that it is inheriting from cutscene element base, which is where we see this virtual execute method. Now we're going to need a couple variables here. The first one is going to be a reference to our camera. We'll just call this cam. We're also going to make a serialized private vector2, which is just going to be the distance to move. Now with that script started, we can go to our cutscene base game object in Unity, which just has the handler, initiator, and also a collider. And now we can add our CSE _ camera pan. You'll see here that there's two different elements already. We have duration. In this case, I'll have the pan happen very slowly over 2 seconds. And the way this is going to trigger is that if I just move this box collider, as soon as I walk into its range, it will trigger the event and start the pan. Now in this case, I want to move to the right a little ways. I'm going to just put 5 for now, and I'm also going to want to move it up since Willard will be down low. So we'll go up by about 2 units. All right, so first of all, we need to actually fill this camera reference. For this, we're going to head to our cutscene handler. So here we'll make a public camera called cam. Now in Unity, we'll have this box here that we can put our main camera into. Now in order to make it so that we can actually get at that camera reference, we're just going to go to our cutscene element base. In the first video, we made this private, and we did it so that it wouldn't show up on every single element in the game, which is a smart move. However, it does need to be public so we can actually access it. So what we're going to do is we're going to turn this into a property. Now to do that, we're just going to add a curly bracket with a get private set modifier. And so it just keeps our inspector clean, but still gives us the accessibility of a public variable. Now let's write this camera pan element. So as soon as we call it in execute, we want to make sure that it knows that the camera is equal to the cutscene handler.cam. And next we're going to create a coroutine. So we'll make a private enumerator called pan coroutine. We'll then call the coroutine, so immediately after finding our camera, we'll go start coroutine, pan routine. Now to make our camera move nice and smoothly, we're going to be using a lerp function, or a linear interpolation. So we're going to need to put a bunch of variables in here. So first off, we need to know our original position. So we'll make a vector3 with that name, and it'll just be equal to the camera's transform position. Then we also need to know where we're headed. So we're going to make another vector3 called our target position, which will be equal to the original position plus, and here we're going to make a new vector3. We're just going to add our distance to move x, our distance to move y, and then we're not going to add anything to the z. So we'll put a 0 there. So now our camera knows where it needs to get to. Now that we've got the positional thing set up, we need a couple of time variables. So we'll make a float called start time, which will just be equal to time.time. Then we need to know our elapsed time, which is going to start at 0. And with all those variables created, we're ready to actually start the loop that will actually make the camera move. So here we're going to make a while loop. And essentially, as long as our elapsed time is less than whatever we've set for our duration, it's going to keep looping through these elements. Now first we're going to make one final variable. This is going to be a float t, which is going to be equal to our elapsed time divided by duration. And at long last, let's move that camera. So let's make our camera's transform position equal to vector3.lerp. So that vector will just continually interpolate between 2 points. Those are our original position, and it's going to move towards our target position. And the last parameter here is going to be t, which is just a step, meaning like what step of the movement are we currently at. Now each time we move the camera, we want to update our elapsed time, which will be equal to just the total time we've been playing the game minus the time this started at. So if it started at 30 and the current time is 32, our elapsed time will be 2 seconds, which means that this coroutine is done. Now we're going to add a yield return null. And this is going to make our pan coroutine no longer have an error, as it's finally returning something. And what we're doing essentially is allowing the frame to finish. At this point, we just add a quick line to double check that the camera made it exactly to the correct position and isn't fractionally off. At this point, the cutscene element is complete, so we can just tell our cutscene handler that it's time to play the next element. Now later on in the series, I'm going to create a video with custom triggers so that we don't have to wait for every element to finish before we can trigger the next one. But for now, we're just going to let this one play through to the end. Now we could stop there, but because we want to write good code and not just workable code, there's one last line we're going to add here. We want to make sure that our coroutine gets stopped if we, for example, leave the scene while it's still playing. And so we're just going to go to private void on destroy. And so at this point, we can call stop all coroutines. So now when we get in the game, as soon as we walk into that trigger, you can see we get a 2-second camera pan, which worked out really nicely. Now, just in case you happen to be using Cinemachine, I want to show how we can make a quick adaptation here so that this also works with the Cinemachine camera. To do this, we're just going to add a namespace, so you can put using Cinemachine. We'll make a reference to a public Cinemachine virtual camera, which we'll call VCam. And I'm just going to leave the public camera reference up there, as we will actually need it later on. Now at that point, we're just going to change our cam reference in the camera pan, so we'll add using Cinemachine. We can now change this to Cinemachine virtual camera instead of a regular camera, and we'll make sure to call it VCam. And then we just need to make sure all of our camera references are turned to VCams. Now if we tried to run it at this point, it wouldn't quite work, and that's because our Cinemachine camera has this follow box, and it's currently set to follow my main player. And so that is going to override anything I try to do in my script. So in execute, once I found the VCam, I just want to make sure that the VCam's follow box is set to null, so the player's no longer in there. So with that, we can now enter the trigger and get a nice smooth pan over a 2-second duration. All right, I hope you've found this one helpful. If you have, please be sure to like, subscribe, or leave me a comment, and be sure to let me know what sort of elements you'd like to see for your cutscenes. Till next time, this is Matt with Nightrun Studio. Cheers.